Good afternoon. I'm Mike Smith. I'll be co-teaching this course with Professor Bailey. You just saw a brief introduction to systems engineering by way of a interface between two components in a natural system. The crashing waves on the seashore of Maine, where I was sitting last week about this time, and behind me you see the evidence of a built system in the form of palm trees on the west coast where the sun is setting over Newport Beach. I'm sorry I couldn't be with you this afternoon for the first day of class, but I promise I'll be there the rest of the semester. I do want to just give you a little bit of background as to who I am and what I hope we'll accomplish over the next semester as we work together to try to develop some systems engineering skills. You probably have heard an introduction from Professor Bailey already. He went to that basketball school down in Durham, but I went to a real university where they don't emphasize athletics at all. That would be the University of Tennessee in Knoxville, where I did my undergraduate work in industrial engineering and then graduate school, PhD at the University of Missouri in Columbia, Missouri. At the time I went to school, systems engineering was not even a recognized discipline, or at least it was certainly not formalized to the point of having academic departments that were given that name. However, a lot of the things that we learned in industrial engineering and operations research programs come from the same roots that we find in systems engineering. Some of it comes out of control theory that's taught in EE courses. Some of you who are electrical engineers that are in the Technology Leaders program probably are taking some courses in control theory, or if you haven't, you soon will. One of the things that I like about systems engineering and related topics is the broad application. What you'll find is that system engineers are practicing in transportation and healthcare and national security and manufacturing and finance, solving energy problems. They're working in government agencies, in the commercial world, in the finance world. You'll find them in a variety of places where you might actually be surprised. I spent about 20-some years working in Northern Virginia at Science Applications International Corporation, a company that does lots of work for government agencies, and had the opportunity to work in national security area, homeland security, in the last 15 years or so, primarily in the transportation area, and I still do some consulting work in transportation. As a matter of fact, this week the meeting I'm attending is dealing with some transportation security issues for the Department of Homeland Security and the U.S. Department of Transportation. Let me just say a word about my view of systems engineering and systems analysis. I really think it's a new way of thinking. It's a way of thinking that perhaps you've not encountered in the past. Many of you came from excellent high schools where you excelled. You wouldn't have been admitted to the University of Virginia had you not been an excellent student. So I know you were all good students or you wouldn't be here. And obviously you made it through your first year, so that must mean that somehow or another you believe that engineering is a career path worth pursuing, and systems engineering in particular for the vast majority of you. For most of you, academic success has meant learning things and being able to solve problems, many of which have correct answers. Some you can even check with the answers in the back of the book. One of the things you'll find as you learn more about systems analysis and systems engineering is that rarely is there a correct answer. There may be better ways to approach a problem. There may be some answers that are better than others. But in general, we're not going to find the answer in the back of the book. And more than likely, Professor Bailey nor myself will be able to tell you whether you have the correct answer. We will be able to critique the way you thought about the problem and perhaps give you some guidance on how to approach the problem in a more successful manner. Systems thinking usually begins with understanding goals and objectives, with developing good metrics, understanding how to generate and evaluate alternatives. But it also deals with lots of complexity, trying to make sense of things which we can't describe and often don't understand very well, but we know influence the behavior of systems. One of the reasons that I find the Maine coast so fascinating is that every time I look at it, I see something different. And that something different is a product of interactions that are described by physics but are very difficult to predict. We've got the tides, the winds, the rocky shores, and obviously when you see the interface between the tides and the shore, something happens that can be extraordinary to the point of washing people who are standing too close to the shore into the cold water. Fortunately, I wasn't quite that close. And then when I look at the environment, and I'm sitting in right now, and I see the Southern California environment that's dominated by the built environment, where the systems are not natural systems but are man-made systems, and have an entirely different set of complex relationships that we find difficult to predict or forecast. And sometimes we build these systems without fully appreciating all the consequences of what we've done. One of the challenges that we face in systems engineering is figuring out where to draw boundaries. What should I include in my analysis and what should I exclude? We know that whenever we draw a system boundary, that boundary is an artifact of our thinking. It either reflects our perspective on a problem or perhaps the range of resources that we or our client have available to guide us in what we really are allowed to do within the constraints of the problem we're addressing. Anyway, I think you'll find this course to be challenging. We've tried to set it up in a way that will give us some indication of whether you're learning things or not, but the way that we are evaluating you will really depend a lot on how much effort you put into the course and how you're able to give evidence that you're really grasping some of these complex ideas. Look forward to meeting you personally on Thursday, and until then I wish you well, and I will see you on Thursday. Have a good afternoon.